on. Hey everybody, this is Larry. This is Biweekly Contest 110 on Leetcode. Doing the virtual contest, everything is as live as it gets. Even though I missed the contest earlier today because I went on a hike upstate New York for like 13 hours and like 15 miles, and everything is very tiring and sore. But yeah, each poem will have his own video on YouTube, so definitely use the search button and all these things. I'll always have a link on the description. But without further ado, let's get started. I'm gonna go sleep at a reasonable time, so let's finish this. I'm gonna scroll down very slowly so I don't get spoiled by the problem names. Okay, they should make you click on the button. All right, am I ready? All right, let's go. Click on another button. Okay. $100. What the? Man, there's a lot waiting. That means if it's 5. Okay. There's a lot of rules. The purchase amount is rounded to nearest multiple of 10. Okay, fine. So. Okay. Something like this, right? Really awkward. I'm gonna get something wrong, am I? I really want to test this. I guess 15 is a test, but 4. Better a couple more seconds than if I went to the closest, right? Alright, YOLO. I'm gonna get a wrong answer and I'm gonna be very sad. Alright. Insert GCDs and like this. Should I cheat on this one? I think I could do it without cheating, maybe. Okay, fine. By cheating, I mean creating it into an array and then doing it. Maybe I should do it that way because I'm gonna get some silly wrong answer from it. Alright, fine. Let's just cheat. What am I doing? Don't do this during an interview. Wait, what am I doing? I think this is sub greater, but okay. It's this, right? Okay, yeah. Just want to make sure. And now, let's just get this over with. Big money. Is that right? I don't even know. Probably. Well, I mean, well, the example inputs, not the problem. Alright, let's go. Minimum seconds to equalize a circle array. What does that mean? You circle each second. For every index, replace num sub I with either num sub I or the previous number or the biggest number. Oh. 1 second and then 2 seconds. Okay. I guess the linear thing is just to do. Yeah, okay, fine. That's not even the right thing, but okay, fine. And then what is the time? The time is the max, or the so for each one we want the maximum. Yeah, okay, that makes sense. Just end maybe. Yeah. For whatever, let's just do for I in range of length of Q, right? And then now you have QKI is the current number, and then next number I plus 1 to the, oh yeah, right, and then now the delta is just right, and now it would take delta plus 1 over 2 steps. So then now we want to max this, right? So longest you gotta if maybe I have to special case it, I don't know. If this is one element, then longest is equal to n over 2. Is that true? Maybe I'm off by some stuff. I have to whoops. Okay, so if there's one space in between, okay, the 2 space is 1, but this subtraction is not quite right. So the number of spaces is -1. Yeah, right. And then this is the number of spaces on the. Is that true? Oh yeah, no, it'll go around, so that's fine. And then this is this one right? Because otherwise this would just go to 0. That's why, and we don't want that. If there's only one element, there's n minus 1 space. So this is actually just n over 2. Okay. Hopefully this is good. 101. Well, not good at all. Why is this 1? This is 1 because longest is 1. Delta would be, this is 1. This should be 0 for all of these, right? Oh, because it loops around. I forgot to handle that case. Then it's 0 and 3. 3 and 0. Okay. Yeah, this is weird. If nx is less than current, nx we add it to n. I think that makes it a little bit better. And then now we nx minus current. Okay, there we go. I'm just doing the. Okay, I wasn't sure about that one. All right. I mean, in terms of just like edge cases and stuff like this. All right, minimum time to make array sum at most x. Every second, y use num sub I, num sub 2 sub I. Okay. After this is done, you can do a for operation. Minimum times you get sum of it is less than or equal to x. Or -1 is not possible. How many people have gotten it so far? Wow, no one has gotten it yet. I'm assuming greedy doesn't work. 10 to the... Huh, I didn't even look at the constraints. 10 to the third. What is it, 1,000? Why don't you say 1,000? Okay, whatever, it's fine. What does it mean? Can I do DP? What is X again? Oh, that's the number that I have to less than or equal to. What does making a number 0 mean? So okay, so we call this every time we add the sum of nums 2 except for one thing that we also make 0. Ten to the 6. Oh, that's the number that's smaller. That's fine. It's not commutative, it's not distributive. The timing matters. Well, we're going to make at most. Is that true? I guess not actually. I was going to say that we can make at most n moves, but maybe maybe you want to do the same place more than once. For example, if one of the numbers really big on nums 2 or something, like disproportionately, then you would do like every other step, just to kind of. No, is that true? No, because then that means that if that's the case, you would reduce it to doing that big step last instead of doing it multiple times, right? So that means that by that definition, you would do each location or each index at most once. And if that's the case, what does that mean when that's the case? Looks like Larry's not sleeping early tonight. the minimum, so we have to minimize as well. I think I get the iterative process if I'm able to kind of build more from it. Basically, the idea is building backwards, maybe. And then if we could build backwards, then we can do a binary search, maybe. 10 to the third is 1,000. If we iterate 10 to the third, no, I mean that's just 1,000 times binary search, maybe on a step. That should be fast enough if that's right. I don't know if it's right though. And we greedily choose okay, so if we look at it backwards, what does it mean? Actually, we don't need to even binary search maybe then, if we're looking at backwards. Because we can just a priority doing it. Okay, let's say we're applying the operations backward. I think that's the way to think about it in time. So then now maybe you can do greedy. So then we choose one number to be 0. We choose the second number to be num sub 1 plus num sub 2, and then the third number will be num sub 1 plus no. So okay, we start at 0 for the first number. The second number it'll be num sub 2. The third number will be num sub 1, or sorry, num sub 2 times 2. And that means that we should be able to use sorting. Because basically we assume that the rest is not being used, and then we incrementally build on that. How many people are there now? Still no one. I don't know if that's right then. I feel like people are very smart. How? I don't remember how to do this anymore. We'll sort by num sub 2. I guess I could just zip them and then sort that as well. We want to actually maximize this, and maybe maximize this as well. All right. And then now, so the total score, let's say we have 0 iterations. 0 iterations is just, okay, so the current is going to be sum of num sub 1, right? And then now for each choice, maybe that's why I have to do n square, because I'm a little bit sloppy on the get min. Maybe, I don't know. Okay, so okay, so now what? So we choose one of these and make it 0. Now we choose one of these. We Okay, let's focus one step at a time first. So we first choose of these, and we make them 0. And by that logic, we want the max item, right? So okay. I guess we can just choose. Do I need the index? Yeah, I need the index. That's why I do it this way. Okay, fine. Okay, fine. It's a little bit awkward. If not used by and b, or we want to try the max. Okay, and then at the end we set this equal to t times nums2 of this, and then use the biggest index is equal to true. Okay, so we set current we want to okay, fine. If current is less than or greater, we turn 0, I think. Otherwise, okay. So we add this, which is fine, but we have to subtract a bunch of stuff. So we made it. So okay, so we subtracted by num_1 of biggest index. We replace it by string. Okay, that's fine. And then the next step, there's a bunch of other stuff. Okay, so that's step 0, right? Okay, so that's step 0, and then now step 1. What am I doing? Step 1, I'm still looking at the biggest index. That's fine, and then I replace it with t times. Okay, that's also fine. Wait, is that true? No, you want the biggest delta, so that's not quite right. You want to read the biggest index such that this minus nums_1 of, oops, something like that. Okay, and then now for the rest of it, I might have to even do other stuff. So that means that for the stuff that's not used, we actually add an extra thing. So the nums2 total, we actually subtracted by am I doing this right? This is so much to juggle in my head. Nums2 total is the sum, and what are nums2? this makes this part a little bit off if I just subtract it by, or if I added. Basically added, but then something is a little bit off the T part. Because in this case, then you don't just subtract this. What do you subtract? Oh, is this? I guess in that case, I don't even need. One, two. I just need this then. This is very awkward. I don't know if it's true. Take a look real quick. What it looks like. Nums is not defined where. Three and -1. I'm still not confident about the solution though. In fact, there's only 6 people on it. All right, let's YOLO this. Now I should at least test something that I know. All right, let's. I don't know. Let's run this real quick. Okay, that's too small. Really? That's still too small. Yeah, because it's less than 10. Is that true? After one iteration, you have 2, 4. Yeah, I guess that's true. I'm just going to YOLO submit and get a wrong answer and then figure out that way. So I don't know how to come up with examples this one in less than 5 minutes or whatever. Okay, so this is 16. I'm returning -1. It should be 4. Okay. Of course, don't do this in Codeforce or whatever. What am I doing in Greedy? I'm minimizing. I'm not doing this. This part is wrong. I think what I want to do is this. Oh. So the biggest number is. Can I do it backwards? Am I doing that wrong? Because okay, let's say we do it in 1 step backwards. And you're done. Does that mean that your second step will be optimal? Because now what you want to do is actually minimize. What you want to do is minimize. So what is the cost here? Maybe I need a heap in some way, but what I want to do is minimize something. Okay, so that means that if that was doing at first, then that would be plus num_1. I see. So then now you have to choose which one to. Yeah, maybe my greedy is a little bit off in how I structured it. Expected 4. How did what am I? So the way that I would order it is the 10944, which is cruelly wrong, because the 4 and the 4 has the 4 multipliers. Maybe I do need the binary search. N times n log n is a little bit slow though. 10 mil. The binary search would solve this, I think. But it is genuinely maybe a little bit too slow in Python. 10 million, yeah. Also, yeah, if I did it this way, I could just use indexes, which I kind of threw away. Can I do it without binary search? Let's see if this is fast enough, I guess. I don't really have any ideas about it. If this is good, what happens then? We try a smaller number. So, okay, so I did it. Maybe I should switch language as well, but that's besides the point. Alright, let me just simplify it. Okay, and then now we can change this formula to but now we add okay, that is done now. What do we do? Well, we set it to 0, so then we subtract this. What am I doing? No, I don't even need this anymore, actually. That means that we chose I, and I is going to be so this is the maximum. Maybe I'm doing this wrong. This is the maximum thing. If we don't choose it for this stage, if we do choose it, then it's just this. Oh, then that means that I have to subtract this to do it. Oh, this is not a thing anymore. Well, that's unfortunate. Because mid is good. You want to do 2 steps? Is that true? 0, 2. Oh, I have to add everything else, that's why. No, I don't need to do this. It's -3, -1. I think this is -1, and this is. Huh, I still get it wrong with 4. Why? 4 is 2 is too small, so then now tries 4. 4 is 18, is the smallest. It should be 16, is it? Why? So by greedy. Maybe my algo is just really wrong, to be honest. I don't know that my algo is even right, clearly. So you do 3, okay, and then 0. So then now this is 4, 2. So then now this is 2, so that's 6, and then 1. So now that's just 12, right? 6. Yeah, so that's 18. I guess that's wrong. That's definitely wrong. Well, I mean, the calculations is right. The answer is wrong. Okay. Huh. What is the right way to do it then? What is the right order? Ten to the 9, or 10 times, I mean 19 if we don't do it at step 0. Man, I don't have any idea on this one. A couple people responded, but not that many people still. What is the optimal solution here? Let's say we're looking backwards. You have 9 as the so we want to let's say we take it. This is like so far not right. Okay. Let's look at the pen paper thing. So okay. 19 to 0, right? And then 4, and then 8, and then 2. Did I mess this up? Oh no, this is 3. But that's 15, so that's right. So why am I, so I'm doing the, so I need to do the 4, the 2 sets of 4s if I want to do it right. And the replacement is it's because okay, so let's say I replace this. Am I form this wrong? Say I replace this now. My benefit is actually at the current step, your cost is 12. If we don't replace it, this cost is 11. So for the 4 we have 3, but then 0 and 2. On the second step, that's 11, and that's 12. We replace it, so the benefit here is that it goes from 12 to, if we do replace it, the benefit is the target minus t it's okay. So you have, okay, so what is it? So the before is if you don't replace it at the stage or total stage, I don't even know. If you don't replace it, it is nums1 of I plus target times num 2 of I, and then replace it with t times num sub I. Yes, that's what I wrote. Except that now I have an extra one for some reason. Maybe I kind of messed that up, confused myself. Okay, well it fixes it, but I don't know that it's right. It's just that it fixed one thing. Alright, let's give it YOLO. Oh man, oh well. I mean, I don't know that I have real expectations for this one. So I think it's 4, but the optimum was actually 2. Why? Tell me why. So for my algo, it thinks 3 is not good enough, so that's the reason. So I see. So you can't binary search because at least not the way that I'm doing it, because 3 is no good, but 2 is good. 2, which 2? Say this one and maybe this one. So then now you have 7. Instead, what did I do? Well, let's take a look at. Two is 59. That's just outrageous. Which 2 indexes are you doing? 2 and 4. 1, 2, 1. And then everything. So this is just 3. That math wrong. So now this is 9. That's 20. 25, 40, 32. Did I mess something up? Oh, maybe this part. How did I have 59? Is that true? It should be. At the 2 steps, this is target. Yeah, no, this is right. How am I getting such a big number? 59. Do I really have to like print everything? What? Oh my, how does this pass anything? What a typo. That's what I get for mixing I and index in words. Deserved it. I mean, I don't know if this is right, but it is. It is at least something. Maybe it times out. If it times out, then maybe I will switch to C++. Also, I left this in by accident. Okay, wrong answers. Maybe, I don't know if it's better, but timeout would have been very painful. Because, oh no, timeout would have been great, because then I would just straight up do it. Expected 8. Can't believe I have such silly mistakes there. I guess I can believe it. 8 is 41, which is 40. So I guess we probably have a wrong answer somewhere still. And the greedy is just not good enough in this case. I think we finally got it, the code to be what I would want it to be. Yeah. But maybe it's wrong. Guess 41. That doesn't make sense. So that's a little bit sad. Oh, because it. Okay, yeah, I expect that. Okay, that's good. I mean, it means that I have no idea how to do it, but it's good in the context that I don't think my code is bugged. It's just wrong. Trying to do some variation of the exchange argument. Yep, Alex hasn't gotten it. And Alex, you know, I respect a lot, obviously. But this is not right. Huh. If it's not greedy, then what is it? I mean, this thing we have sorted by it, so this is actually kind of an awkward way of doing it. Maybe. Oh, sorry. How much time do I have left on this one? 36 minutes. I have no idea, so it may be that I just don't know. maybe that this is just sorting, and I'm going because the way that I've structured it, it could be sorting. So what am I doing? That's the replacement. My one is no, this is a different T. Oh no, it's not, but it's I was it was just a YOLO, to be frank. Because I don't think this quite makes sense. I think there's two stages. You group them by the numbers that are here, there, and then you sort it. Or like there are two groups. You partition them, and then you do a. That feels hard. I don't know if that's the way I would do it necessarily. And get a repeated min on it. think audience is here. What the? Oh, I deleted stuff. Whoops. And then I think I had the submission. No, not that one though. All right. How am I so bad? That didn't fix it. Huh. Yeah, I don't think I have any idea on this one. I mean, I'm using like a lot of variations on greedy, and it hasn't really been working in binary search. But the optimal solution would have to the minimal. Okay, so we don't need all this. What is the minimal we're doing? The minimal would be just t times 1 sub I, maybe. Yeah, didn't fix it. It's still 7. trying like random stuff to see if it works. I don't think I have any idea on this one, to be frank. What are you doing? But yeah, I don't know that I know how to do this one. It seems like only 47 people got it. How much time? 23 minutes. Can I grind 23 minutes? Do I even have it? Like, I want to start over. Okay, so maybe it's not binary search or greedy. Is there a DP? I don't know. What would the DP even look like? No, because the ordering matters. No, the ordering matters. I don't know how that I can separate it. Is there a pseudo DP? Does it matter that all the numbers are just, the domain of the numbers are small? So each number is 1,000. There's 1,000, and it takes 1,000 times. So it could be 1,000,000 times, or 1,000,000 plus 1,000, or something like this. And this is just Larry banging his head on the wall for this one. Does the X matter? I mean, does it matter in the solution? So we're gonna use it even almost once. So that's not the right grade, but reorder on the order doesn't make sense. Try to cover functions. Can we DP? I mean, the assumption is that we don't use the same thing once, but maybe we don't need to use that assumption if it's just built in that if you do, you're just silly. No, because then it just becomes an iterative thing if you do it that way, and if the thing was to bound by n square or 1,000 square. I have about 20 minutes left. I don't know that I'm gonna grind it out, even on a good day, let alone on today. I'm grinding hard for it too, but I mean, the simulation makes sense. It's just that I can't find it. I mean, greedy is not the right way to do it, even in a binary search situation. I thought this would be right, but I guess not, so. Let's see. How would this be wrong? I see. I don't think. Yeah, I don't think I could partition it this way. Doesn't make sense because you're making incremental progress. So it is not always. Maybe I just need to be smarter in the simulation. But I feel like if it's just like a smarter simulation by now, more people would have gotten it. So I don't, like in a meta kind of way, I don't think that that's the way to do it. Does X matter? Or is it just a termination condition? Man, I'm going in circles, so I don't think I'm getting this, but. How much time do I have? 15 minutes. Yeah, I'm still stuck on this idea. I can't think of any new idea. If it's not DP, if it's not greedy. It's still an exchange argument. Like a bubble sort? No, you can't do. Just keep on. Binary search of a bubble sort? Would that even make sense? I'm out of ideas, so why not? But then you can't. Can there be like a A is greater than B is greater than C is greater than A situation? That's the only. I mean, why else would you do bubble sort? Huh. Oh, man, if I have energy, I would try to at least stay up for this, but. Yeah, and I think I'm gonna just take a break. I don't think I'm gonna make any progress in the last 12 minutes. So yeah, BRB. Thanks for joining us. Right now. I'm just kind of rereading Q4 of the biweekly. We're trying to learn. Well, a lot of people end up solving it. About maybe 82. That's not a lot actually. So I'm just trying to learn afterwards. I don't know how to do it. I can figure it out. So it's not binary search, but what does this even mean? Let's see if there's a easier. So there is a DP. Yeah, so there's some DP here. I was trying very hard to kind of think of it, but I just couldn't think about it. Maybe I was just very wrong. Let me try to see if I could figure out the recurrence without, or just understanding this recurrence, I suppose. I mean, I had done a lot of these things, but there's an awkward way of phrasing it. But definitely did not get this one. Yeah. So we sort by. Don't know if I could read that one. Oh, I mean, I had something like this, but not the DP port. I guess there is some DP, but I just don't understand it. Can I understand the DP port? All right, let's look at the other, the binary search one first. Let's see if I can understand it. So okay, so let's just say, can we? Yeah, this is regular binary search. Is there an answer with mid? So I was trying to do something like this, but in a greedy way, which didn't work out at all. So I missed the DP part. So I is the number of turns. Where is it? No. So the new array. So it goes up to mid, right? So that means that the hidden dimension is mid, that it gets space optimized away, and these are just the indexes. What is it saying? It is saying that DP of I thought I was trying to. I did think about something like this, but I couldn't really come up with it. But this is saying that the last time it is updated, because she sorted by B. That's why the index is different. I had something like this, but I couldn't figure out the DP. So basically, it's saying J minus 1. Why is the I loop on the outside? That's the confusing part for me. DP sub J is the DP of turn. So DP sub J I would have thought that is the other way, to be honest. I mean, I had this, but I was trying to do it greedy. But, I need a two-dimensional version. Maybe that'll be easier to remember or to understand. Definitely not quite seeing it still. Maybe the two-dimensional version is too slow. That's why everyone has a one-dimensional version. But oh no, this is a two-dimensional version. I don't get why it's IJ and not JI in this case. A very funky way of writing this, but fine. Oh, so this is the total minus trying to maximize Oh, so you're trying to maximize the number removed. And if you remove at a certain point, what is DPIMJ? It is the maximum score remove of item I don't know how the states don't repeat. I think that's the part that I was confused about in general. It's not just Okay, so this is num sub 1 of I. So J of that means that's how much it was. I see, because now you're maximizing all the accumulation that you remove. So that's why you're counting upwards as time progresses. So then now you're maximizing, okay, the first level. So basically you're saying you remove at this current time or you don't remove at this current time. I see. Let me see if I can figure that out. I wrote so much random crap. Okay. But there is the sorting aspect. Why does the sorting matter? I think that's the part that I missed. Sorting by nums 2. Why does the sorting matter? Oh yeah, so okay. Let's go. So we have an index, and then we have a turn, say. Is it turn or step or whatever they call it? Operations? That's fine. And then basically, if index is equal to n, we return 0 or something. Yeah, because you're not removing anything. Otherwise, we basically take or don't take is what they're saying. So if you take, is that right? That feels a little wrong. So if you take it at this time, So you can't take it again. Otherwise, you might take it at a later time. I see why there needs to be sorting, but I don't know that I understand it. Okay, wait. Because if you're trying to sort by nums2, then I mean I get it, but I don't get the proof. This is okay. So we take it, and now the number that you take at that time as accumulated nums of 1 of index times turn. Oh, sorry, plus turn of nums2 of index, right? Something like that, maybe. And then don't take. This is a little bit awkward. But this predicates on the sort, otherwise it doesn't make sense. And I don't know that I understand the sorting right now. So oh wait, no. And then now we do thing. What am I doing? So turn 0 would be so that's the total. And then we subtract it from goal. Oh, in this case, that technically I have to count down. So then I can do return. Oh, wait. Something like this. Oh, whoops. This isn't quite right, I think, but return, so maybe this is off by 1, no, off by 1. understanding needs a little bit more. So the only way that we would change is because it assumes that in future turn this number gets bigger, so in a way we want to optimize for that, I guess. Okay, I mean, I think I'm making sense of it. Don't know if I can come up with it, and we're still a little bit wrong, but unless I did it backwards by accident, maybe. Okay, so if this is 0, then it's 0, 0, then we just return 0, okay, fine. If this is 1, then you have just this, then 0, 1. Seems right. Why am I gonna wrong? Is it supposed to be less than or equal to x, right? Okay. Oops. Man, I'm mixing languages. So removing 0, we have 6, okay. Removing 1, let's say we remove this one. Is it still 6? Oh, I see. This needs to be inclusive. Okay, I was just being dumb. Is this right now, though? Let's just YOLO because I'm... But... Maybe it times out just because I was lazy on it. That's why people rewrote it or something like this, yeah. You know this is n square. That's just Leetcode being silly, I think. And having 1,206, but that means that we're right, but okay. I mean, I was playing around with this idea, but I think I didn't know that I want to... This way of writing is a little bit easier, but I didn't know that I had to sort it by this. I think there's some, like, property that I have to kind of think about it a little bit offline to figure it out a little bit. But for most purposes, this is right. It's just that, you know, we have to... come on, fam. We have to rewrite this or something, like, to be bottoms up or whatever. That's why people did the optimization. And here we can do and rewrite this, right? So we have dp is equal to, let's just say, oh no, in this case we have 0 times the inner was its turn, so turn is going to be n for n, and this is actually n plus 1, right? And then for I in range of n, for j in range of n plus 1, it's just take or not take. So yeah, dp of ij is equal to max of dpi plus 1, j minus 1. Oh, no. And we can probably rewrite this a little bit, but because now the dependency is a little bit off, so we should and maybe we can just expand this to this, right? Right. And now it's just dp of I don't even have the answer for this one, but they didn't give it to us. Our answers are wrong anyway. But because I didn't, I'm missing the base case of j is equal to 0. Oh, and also yeah. Which one is this? Why? Oh, whoops. Let's see if this works. A little bit faster. Definitely more memory efficient. Yeah. So I think this is just like, very straightforward tick, no tick. I mean, and people write it in a number of different ways. But I have to think about how to combine this with the sorting. Basically, the idea is that nums2, which is this portion, the idea is that if you don't do it on, let's say you start with a late turn, if you don't do it on this turn, you're not going to do it on a later turn. Because of the exchange argument in a way. Because that's really hard to come up with. Because basically the idea is that if you either don't solve it, or if you solve it, you do it on the highest turn possible. Because in a greedy kind of way, because we sorted by maximum nums2, in a greedy kind of way, if you don't take it now, it never makes sense to take it later. Because if it did, this term would be as big as it is ever. It's just about the question of this term. And so if you don't take it because of this term, this one will just get a little bit smaller. And because by definition, in the future, this term will be smaller. Yeah. I kind of see it, but I have to kind of, like, is it a proof? No. So yeah. Basically, I mean, it's kind of, it is the exchange argument. And you can kind of prove it by just being with an exhaustive proof. Let's say we have A11, A12, and A21 maybe, and then A12 and A22, right? So the idea is that now you have a thing where you have A11 plus T times A21 with a comparison of A12 plus T minus 1 times A22, right? And given that A21 is greater than A22, this term will always be bigger than this term. Or, well, this term will always be bigger than this term, but this term will be always, so as a result, this term will always be bigger than this term. So then the question is about, so if we don't use this one, but we use this one, there's never a case such that it is more optimal to do this it's never optimal to do this, because by the exchange argument you can just by the exchange argument, because we know that A21 is greater than A22, we can just add A21 on both sides and then subtract A22 on both sides, and then you get and then basically now you have A11 plus, well, you just have this really, right, on both sides. But because you know that this is true, now if we're trying to maximize, this comparison aside, okay, another way to write this exchange argument is not using this question mark comparison, but a plus, right? Because this is we're trying to maximize this function, and the exchange argument is that now, let's say we have this, and we know that A21 is greater than A22, that means that this formula, you could say this in a number of ways, but the idea is that this formula subtract this formula is equal to subtract is equal to A21 minus A22, I think. And because this is a positive number by definition, because as we said, H11 is equal to A22, then this answer will always be better than this answer. So that's why it's either you don't take it, but if you are taking this, if this is the case, this will always be better. This is a good thing. I'm convinced, or it's good enough of a proof, but I'm trying to think, okay, now you have a proof, and now you understand the solution, but does it mean that, or how do you come up with it, right? And I don't know. I'm going to sleep on it, but that's all I have for this contest. Let me know what you think. I do love this problem, but it just involves putting together 3 really difficult things. And of course, if you look at other people's solution, it's basically the same, but it's going to be an explanation part. This is the me understanding part post contest. Do I understand it? Yes. Can I come up with it? I don't know. Probably not, to be frank. Even now that I learned it a little bit, I would have to do. If I have to guess, I would have to do this 3 or 5 times, similar technique before I really get it. But it is beautiful. I do appreciate this problem. I just don't know if I could come up with it, even knowing and understanding. Anyway, that's all I have for this one. Let me know what you think. Yeah. Stay good, stay healthy, to good mental health. Hope you have a great contest. I'll see y'all later and take care. Bye-bye.